Most octopuses dart through sunlit reefs, but far below, where light dies and the water chills to near freezing and pressure could crush a submarine, some become almost unrecognizable. Pale, gelatinous, and eerily slow. Every bizarre trait you will see here is a precise answer to that alien world, not a flaw. These deep-sea octopuses prove that looking strange is sometimes the only way to survive. But just how far can life bend before it breaks? At depths beyond 3,000 meters, the Dumbo octopus drifts in a world shaped by pressure and scarcity. Its body is soft, gelatinous, almost boneless, matching the density of the cold seawater around it. Where a shallow water octopus is built for bursts of speed and sudden escape, the Dumbo's design favors survival in a place where every movement is costly. Instead of jetting through the water, it unfolds a pair of ear-like fins above its eyes and flaps them in slow, deliberate strokes. This quiet propulsion lets it hover just above the seafloor, barely disturbing the silence. Neutral buoyancy keeps the animal suspended, neither sinking nor floating upward, so it can wait for food with minimal effort. Muscle and armor would only waste energy here. Too much rigidity and the body would strain under hundreds of atmospheres of pressure. The Dumbo's softness is not a weakness, but a precise answer to the crushing weight of the deep. When food is scarce and the cold slows everything down, speed becomes a luxury few can afford. Each gentle beat of its fins is a calculation. It is how to move without burning through precious reserves. In this slow-motion world, the Dumbo octopus is a master of endurance, built not for the chase but for outlasting the emptiness. Yet in darkness, where predators are rare and eyes are useless, another challenge waits: how to disappear entirely. Some deep-sea octopuses have found a solution even stranger than softness. In the open water far below sunlight, the glass octopus drifts almost unseen. Its body is so clear that only the eyes, optic nerves, and a thin digestive tract cast faint shadows inside. Everything else, arms, mantle, even the head, blends into the water, leaving behind little more than a ghostly outline. It is transparent. This is not a trick of the light or a rare mutation. It is survival by subtraction. In the deep sea, pigment becomes a luxury. Making color takes energy, and every calorie is precious when food is rare. For the glass octopus, transparency is more than a disguise. It is a way to avoid casting any silhouette that might betray its presence to the low, searching eyes of predators and prey. Where the Dumbo octopus meets pressure with softness, the glass octopus meets darkness with near invisibility. Its organs are suspended in a jelly-like matrix, visible only as pale threads and spots. The rest is nearly invisible, a body built to vanish in the faintest blue glow that filters down from above. This form of camouflage is not about matching rocks or coral. It is about erasing the body altogether. In the deep, even a faint outline can mean death. The glass octopus saves energy by skipping pigment and invests everything in hiding from light itself. Yet this strategy comes with its own risks. Without the armor of pigment or the smokescreen of ink, what happens when a threat finally draws near? In the deep ocean, many octopuses have let go of one of the most famous weapons in their shallow water cousin's arsenal, the ink sacs. For cirrus umbrella octopuses like the Dumbo and the flapjack, this organ has faded away and leaves no trace inside their bodies. In the pitch black below 1,000 meters, a cloud of ink is useless. There are few eyes to fool and no sunlight to block. Producing ink is expensive. It draws on limited energy and nutrients, resources that are never wasted in the deep. Every drop saved can be spent on survival. Instead of investing in a defense that no longer works, these animals reroute their resources. The metabolic cost of making ink, maintaining the gland, and storing pigment is traded for something more valuable in the abyss: efficiency. Predators are rare and encounters are uncommon. When a threat does appear, speed and confusion are less important than simply vanishing into the darkness. Some cirrus octopuses rely on a quick flick of their fins or a subtle change in color, but most depend on stillness and on their ability to blend into the empty water. Without the need for a visual smokescreen, the logic of defense changes. The loss of the ink sac is not a weakness or an oversight. It is a calculated response to a world where every adaptation must pay its way. In the Sirit group, the body becomes a ledger, and every trait is measured against the cost of survival. With defense simplified, these octopuses can turn their energy toward finding the next meal, a challenge that demands its own set of strange solutions. The flapjack octopus drifts in deep water, arms outstretched, webbing unfurled in a thin, translucent sheet. Where other octopuses might dart after prey, this animal waits. Its body hangs just above the seafloor, buoyed by softness and patience. The web connecting its arms forms a living parachute, slowing its descent and letting it hover almost motionless. In the darkness, movement is expensive. Instead of chasing, the flapjack octopus turns its entire body into a trap, presenting a broad, delicate surface to the drifting world around it. Each arm is lined with suckers, discs of flesh that do more than grip. They taste and feel, detecting the faintest brush of a passing crustacean or worm. Touch is everything here. In the absence of light, the arms become the octopus's eyes and nose, mapping the world by contact and chemistry. When a small animal comes close, the octopus responds with the barest motion. Arms flex inward, webbing contracts, and the prey is drawn in, almost as if the water itself handed it over. The umbrella shape is not for show. It is a solution to scarcity, a way to gather food without wasting energy. By spreading wide, the flapjack octopus increases its chances of intercepting the rare meal that drifts by. There is no rush, no pursuit, just a slow, silent wait in the cold, with every arm tuned to the dark currents. Efficiency means survival. The flapjack octopus thrives not by being fast or strong, but by turning stillness and sensitivity into a way of life. On the slopes of a deep-sea seamount, hundreds of Musoctopus females gather in silence. Each one curls over her eggs, pressed into narrow crevices of volcanic rock. Here, a single mother will not move or eat for years. Scientists watched one female remain in place for more than 4 years. Over 1,500 days, she never left her brood. In water just above freezing, her body shrinks as she starves, burning through every reserve she has. All around her, the colony endures the same vigil. These brooding octopuses have only one chance to pass on their genes. Each egg is guarded at the cost of the mother's life. When the young finally hatch, the mothers die, leaving behind a new generation ready for the darkness. In this world, survival is measured not in speed or strength, but in patience and sacrifice, stretched across impossible spans of time. Remotely operated vehicles slip through the dark, their ultra-low-light cameras capturing octopuses that would vanish under brighter beams. AIE combs through endless hours of video, finding delicate arms and ghostly outlines that escape the human eye. To study these animals alive, scientists build pressure chambers. These are steel cylinders that hold the weight of the deep, keeping tissue and chemistry intact for a few precious hours at the surface. Yet even as our tools reveal new species and hidden behaviors, a different kind of machine threatens to erase what we have barely begun to see. Mining collectors crawl across the seafloor in the Clarion-Clipperton zone, scooping up nodules that serve as nurseries for Dumbo and Musoctopus. In test sites, every brooding female and every egg vanishes in the collector's path. The debate rages in distant conference rooms, but in the abyss, the loss is silent and total. Most of the deep remains unseen. Its secrets are fragile, at risk of being lost before they are understood. Less than 1% of the deep ocean has been explored. Every strange octopus we meet reminds us that evolution thrives in darkness, and we barely grasp its limits. As deep-sea mining threatens these hidden worlds, their survival and our understanding of life's extremes hang in the balance. What secrets wait below?